Welcome to Algebra, lesson number 3, combining like terms. Alright, so in lesson number 2, we decided or talked about what makes two terms alike, that they have the same variable raised to the same exponent. In this lesson, we're not going to do too much work with what constitutes like terms. I'm going to give you pairs of terms that are alike, and we're going to just practice combining them, putting them together, since that requires a little bit of practice as well. So let's jump right to example number 1. We're going to combine the following two terms that are alike. So here's our first one, 2x plus positive 9x. So combining like terms is just like combining integers, and I'm going to spend just a little bit more time on this first one while we look at this. Now what this one is saying, our first term that we can look at, and we're going to go back a little bit to older discussions that we had about integers and the way that we would combine them. We are going to talk about x's. Remember, x's in our first term and second term, because they are alike, the number that we don't know is identical. It's the same quantity. So we have 2 of them, whatever they are, and we have 9 of them, whatever they are. We have 2 of them and 9 of them, so if we were to write out the first one, plus 2x's, it would look like this. We have 1 of them, and we have 2 of them. The second one would look like this. Plus 9x would look like 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So there are our x's. We have 2 of them up here, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 of them right there. And when we combine them, if we look at this grouping holistically all together, well, we can see that if we count them up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them. We are going to have 11 of whatever that thing is we don't know. In this case, we're keeping the same variable, x. So we have 11 x's. So if you look at what we've done, we've taken the coefficient of these terms, the plus 2, or the positive 2, and the positive 9, and we've combined them. And we now have 11, and then we just keep the variable, and the variable is x. If you wanted to say x to the exponent 1, or just x is fine. So we have positive 11 x's after we combine them. Let's have a look at another example. Again, we'll talk this one through. Same idea. We're going to do this one a little more involved than some of our other examples. We have positive a to the exponent 3 plus negative 5a to the exponent 3. So let's write these out. We'll get a look at them. So this is, so we have positive a to the exponent 3. The coefficient in front of that, because it's not written in there, is going to be a 1. So we want to write it in, especially if we're having trouble remembering it. So positive 1a to the exponent 3. If we were to write this out, we have 1 of them. So that's only 1 plus. Whatever a to the exponent 3 is, it's a thing, it's an unknown amount. We only have 1 of them. Our second term is negative 5a to the exponent 3. And again, whatever a to the exponent 3 is, we have negative 5 of them. So we're going to write that as 5 negatives. 1, 2, 3, 4, 5. So now we are going to, as we were when we were working with integers, we are going to draw a little box around pluses and minuses, a positive and a negative sign that match, because remember, they undo each other. We add one thing, we take one thing away, the net change is 0, so we can just put a line through that. They've undone each other. They're gone. And what do we have left? We have 1, 2, 3, 4 negatives. So our answer in this case will be negative 4. What was our variable? A to the exponent 3. So again, just to reinforce this, what we're combining are the integer components. Same ways we've always been combining integers. We're going to move towards doing this mentally in the next examples, but it's the same thing, same idea. Combining our coefficients, like integers, and then we are keeping our variable, a to the exponent 3. Okay, enough explanation. Let's get into this. Example number 2, we're going to combine the following two terms that are alike. Plus 3y minus plus 4y. Okay, this one's not too bad, but you'll notice that when we're combining, we like to have an addition sign in between, and we have a subtraction sign here. So we want to change that first and foremost before we do any combining. So I'm going to change that subtraction to addition, but in order to do that, I have to change the sign of the term after it as well. So that is no longer a positive 4y, that is now a negative 4y. And now I'm going to write these out quickly. I have plus 3y. That's going to look like 1, 2, 3 of those. And I have minus 4y. That's going to look like 1, 2, 3, 4 minuses. I am now going to combine these. And I am going to put a line through the ones that undo each other. And when we look at what remains after we've paired up all the pluses and the minuses, we'll notice that we have left 1 negative. So we have 1 negative and our variable y. That's how we tackle the first part of example 2. So here's another one. What I'd like you to do here is hit pause in the video and give this one a try on your own using the steps that we've gone through today, remembering back to our work with integers. Let's try this one. You guys try it on your own. Hit pause, come on back when you're done, have an answer, and we'll see how you did. Okay, let's get a look at this. Again, you'll notice that though we're combining them, we have a subtraction sign in there. We want to replace that with an addition sign, as long as we remember to change the sign of the term immediately after it. So in this case, that's a negative 3b squared. Now that is a positive 3b squared. So let's write these out quickly. We have negative 6b squared. That's going to look like 1, 2, 3, 4.